Okay, guys, since we could not be together to finish or even start our geometry review, we're going to go through it now. I'm going to have this video so you guys can watch it here on YouTube and look through every question. Just bear with me because I have to work them all out at home. Okay, so the first one is sketch which figure you think will be next in the pattern. We see that the left triangle is shaded, then the top triangle is shaded, then the right triangle is shaded, so you know the next one has to be the bottom triangle being shaded. So you're going to just have that shaded in. And we see that would be the next pattern. Once again, over here, we're looking at the triangles. So you know you're going to have a triangle. You have the top triangle, then you have the right triangle, then you have the left top of the right part, and then that means we're going to come right back around. And your next one is going to be up top again, because you're hitting all three corners. Looking at this one, let's see what would be the next number we'd expect. So we're looking here, well, how did we get from 21 to 31? Well, we had to add 10. How did we get from 31 to 41? You got to add 10. And we see that pattern continuing. So to get from here, we know the next number would have to be 61 because we continually add 10. 61. Now looking at this one might be a little trickier to see since you're starting off with a fraction. So you see that you have negative 1/3, and we get to 1, and then we get to 3, well, negative 1, negative 3, negative 9. And if you're looking at this pattern, you see the difference here is that we're going by multiples of 3. So we're here, it's going to be times 3, times 3, times 3. So that means our next number would be negative 9 times 3, which would be negative 27. Okay, conjecture. Complete the conjectures by providing 3 examples of how you can have this conclusion. So the sum of 3 odd numbers is always, and then we want to figure out what that would be. So we're just going to pick any 3 odd numbers, and we'll see what happens. 1 plus 1 plus 1 equals 3. If I want to mix it up, I might have 3 plus 1 plus 5. So that gives me 8. 9. So we now have 9. And the next one maybe mixed up again, 11, 1, and 13. So that gives me 24, 25. Well, looking at these, I've now provided 3 examples. We see that all 3 of these numbers are odd. The square of a non-zero number is always, so we have a few of these that we really like. Non-zero, so 1 squared, negative 1 squared, 3 squared. So 1 squared we know is 1. Negative 1 squared is 1. And 3 squared is 9. We notice no matter what it is, as long as it's not 0, because 0 is considered to be not positive or negative, it's going to be a positive number. Okay. I'm going to pause. Well, I might be able to fit it in. So show that the conjecture is false by finding a counterexample. So it already tells you that it's false. Make sure you're reading it. And then we want to find a counterexample. The quotient of any 2 whole numbers is always a whole number. So 2 whole numbers, quotient's division. So a good counterexample would be 2 divided by 3. It's not going to be a whole number. It ends up being 0.6 repeating. Okay, so if today is a day that starts with the letter T, then yesterday must have been Monday. So a good counterexample to this is, well, we have 2 days of the week that start with a T. We have Tuesday and Thursday. So if it was Tuesday, the day before this would be Monday. But if it was Thursday, the day before this would be Wednesday. Okay. This one looks weird without my computer at work. I'm going to try to show this. All these dots below here are actually the points. They're just supposed to make it where you can see these a little bit easier on here. Well, you see that P is the capital letter in the corner. We know that that's denoting a plane. See if I can get it to right. P. Over here we have G, just so you guys can see what it looks like. I know you can see it a little easier on yours. We have F. And then up here we have E. I think that's the only one we're really missing. Okay, so we want to name 4 coplanar points. So 4 points on the same plane. Well, if you look at the top shaded gray plane, we only actually have 3 points on that. P is the name of the plane, so it's not a point. But on the other plane, the white plane, we can see that we have 4 points, and those points would be A, B, C, and D. Put those around them to show that this is a set. You don't have to do that because we didn't really talk about it. So name 3 collinear points, so 3 points that lie on the same line. So once again, if we look up the top, you see that F, G are the only 2 points named on that line, but A, B, and C are all on the same line. So once again, I have A, B, and C. I do have one other thing that's hard to see on here. It's even hard to see on your page. I'm going to draw that one in. Right here, we see that that's line, and on my page I wrote line L. So that's a little L. So name 2 coplanar lines. Well, you'd have to use that. You have 2 options here. We could have had line L and line, if we're going to use the gray plane. Remember, we use 2 letters, and we can name it FG, line above it, arrows on top. So line FG, or we could have had line L, and then you can use any 2 letters on A, B, and C. So you could have AB, BC, AC, BA, any combination of those. My other one would be line, I'm going to go AB. Okay, and then up here, the last one is name the plane that contains E, F, and G. So the plane that contains P or E, F, and G would be plane P. Plane P. Or if you're going to label it by points, remember any 3 points, plane E, F, G. Again, these points here were just a typo. They just didn't copy over well. I'm not sure if I have another picture of this next part. So we're going to do 13 and 14 here. And if we have them on the next one, then we'll continue on. So 2 lines that intersect at more, or 2 lines intersect at more than 1 point. So is it possible to have 2 lines that are going to cross at more than 1 point? So we have the possibility that they are the exact same line, but that's not exactly what this one's talking about. So we're going to say that this one is false, because it only intersects at 1 point, unless it is the exact same line. A line contains more than 2 points. This is true. A line has infinitely many points on it, so true. Okay, I'm going to switch our slide. Well, it turns out I did have this on this slide. So now we're going to go on to 15. The intersection of 2 planes is a line. So I'm going to try my best to draw this. You have the first plane. Looks like a sheet of paper. The second plane cuts straight through. Well, where did they intersect? They intersect right there in that middle, which is, in fact, a line. So think about what our classroom looks like. And when the wall meets the floor, does it just meet at 1 point, or does it meet the whole way? We see it just meets at the crease where the 2 touch, which would be the equivalent of a line. So we're going to say true here. So now we're going to use the diagram to answer the following questions. I think you're able to see that one okay. So name the intersection of EB and BC. So if you're looking here for EB and BC, the intersection would be B. See, it's meeting right here. But you also notice that the letter that's in both of them have a B. The next one up says, name the intersection of plane ABC and FA. So plane ABC, let me erase what I had. Plane ABC is this portion of my triangle, and FA is this line right here. Well, where does that plane and this one meet? Well, we see they meet at A, that little corner. Name the intersection of plane FAB and plane ECD. Let me erase what I have. We see here that I have FAB, which would be this side over here. And it's going to intersect with FED, which is the back triangle. Well, where does it intersect? Well, we see it intersects at, sorry, give me a second. I think I read the wrong one. So FAB and ECD. So ignore that last part. So FAB, that's still the red one I have there now, and ECD would be this plane right here. We see that they meet at EB, that line right at the top. Right here is where those two planes intersect. It's like where the two parts of your roof meet. Okay, name the intersection of plane ABC and plane FED. Okay, I'm going to erase this one more time. Okay, so we see that plane ABC is this front plane, and plane FED is that back plane. You can't see it all the way, but it's another triangle back there. And where do they intersect? Well, we see they don't. None. Don't intersect. Okay, now we're on to finding length. So we want to find the length of AB. AC. So what we see here is we have AC equals the length of AB, which is AB plus BC. We know the length of AB is 11. We know the length of BC is 5, which means that AC has to be 16. I know that some of you guys can see that quicker, but this is the mathematical support that goes along with this. We also now have here, we want to find the length of QR. That's this portion right here. So we want to find QR. Well, QR is part of the whole. Let me erase that. So the whole line is QS. QS equals QR plus RS. We're substituting what we know. We know this is 21. We don't know QR, so we know it's X. We know RS, which is 13. To solve for this, I'm going to have to subtract to get X by itself. We get X equals 8. So QR equals 8. Okay, let me pause while I clear our slide. Okay, so here we're looking for angle, the measure of angle ABD. We see that's the big angle. So the measure of angle ABD equals measure of angle ABC plus the measure of angle CBD. And you can see you can arrive at that by doing 45 plus 60, which gives you 105 degrees. So total angle will be 105 degrees. Over here, we want to find the measure of angle NML. So that's this portion right here. We know the whole angle, the measure of angle KLM is 155. And we want to find the other half, so we can take that measure and we can subtract the measure of angle KLN to find the measure of angle NLM. So that gives me 155 minus 63, which is going to give me, if I did my math correctly, 92 degrees. Line L bisects the segment. Find the lengths of the segments. Well, if it's been bisected, what does it mean? You guys know I go, ka-cha. Bisect means cut in half. So we know that JL is 17. That means KJ also has to be 17. So I know that KJ equals 17. And that means that KL equals 17 plus 17. Which should give you 34. Over here we have PR and PQ. Once again, bisected. You see the little tick marks denote that. That means that this part here is 5.7. So that means PR equals 5.7. And then to get PQ, it's going to be 5.7 plus 5.7. See if I can get that, which should give me 11.4. My little stylus isn't working the best right now, so I'm trying to bear with it. Our next one is midpoint, so we should be at the top of the 3rd page right now. We have a midpoint formula. If you don't remember it, you should write it down. We have x1 plus x2 over 2, y1 plus y2 over 2. Excuse me. So I know that some of you guys are still confused at this. So remember, this is x1, y1, x2, y2. Goes in alphabetical order. So if we're going to do our x1, we have 0 plus 8 divided by 2. And then y1 is 0 plus 2 divided by 2. So 0 plus 8 is 8 divided by 2 gives me 4. 0 plus 2 is 2 divided by 2 gives me 1. So 4 comma 1. We're going to use that same formula here. x1, y1, x2, y2. Okay, so x1, 4, x2 is 2 divided by 2. y1 is 7 plus y2 is 13 divided by 2. Well, we see that 4 plus 2 is 6 divided by 2 gives us 3. Over here we have 7 plus 13, which is 20, divided by 2 is 10. And the next one up, same idea, x1, y1, x2, y2. We have negative 3 plus 5 over 2. We have negative 6 plus 4 over 2. There shouldn't be that parenthesis there. That was just me being excited. Okay, so when I do this, I have negative 3 plus 5. So that's the same thing as 5 minus 3. So that's 2 divided by 2, which leaves me with a 1. And then here we have negative 6 plus 4. Well, that's negative 6 plus 4 gives me negative 2 divided by 1 gives me a negative 1. So we have 1 comma negative 1. Okay, I'm going to switch my slide. Looking here, you see that it says that ray QS bisects angle PQR, find the angle measure. So once again, bisects, cuts in half, means 2 congruent pieces. So that means that SQR also has to be 11. So the measure of angle SQR has to be 11. And since it's being bisected, we know that the measure of angle PQS is going to be 11 plus 11, which is 22. Here is the reverse of what we just had. Instead of having one of the smaller angles, we actually have one giant angle measure. You see how it's a continuous arc all the way down. So here we know that this is going to be bisected, so it's cut in half. So to find either of these angle measures, we know that the measure of angle PQS is equal to the measure of angle SQR, which is equal to half of 121 divided by 2, which should give you 60.5 degrees. Next one up says it's been bisected again. We know that each half now instead of a total. Well, if it's been bisected, we know it's been cut into 2 congruent parts. We can set those 2 congruent parts together. 31 equals x plus 15. And subtract over 15. Okay, so we have 16 equals x. 6x minus 4 here, same setup. We have the 2 smaller parts. We can now solve. Equals 56. Got to get x by itself. Add 56. We get 6x equals 60. Divide by 6. X equals 10. Okay, here is all about complementary and supplementary. So it says C is the complement of D. So if we know that C is 57, well, how do we find D? So remember, my line with this is being complementary is what's right. We like to give compliments. People like being right. So we're going to do 90 degrees because it's being right. Right angle is 90 degrees. We do 90 minus 57. Let me do some math real quick. So if I add a 3 at the back, we know it's going to bring it up to 60, so 33 degrees. Our next one up, we see that the complement of F is going to be 9.5. So again, complement 90 minus 9.5, which gives me 80.5. Next one up is supplement, so that means 180. 180 is minus 37. which gives us 143 degrees. Supplement again, so 180 minus 114.5. So that would give me 65.5 degrees. And the next one tells us that 1 and 2 are linear pairs. So what does it mean to be a linear pair? So a linear pair has adjacent angles, so they share a side, and the non-adjacent sides form straight lines, which brings us back to it being supplementary because a straight angle is 180 degrees. So we do 180 degrees minus 47. 180 degrees minus 47 is going to get me 133 degrees. And then the next one's about vertical angles. So remember, vertical angles are our kissy fish. That's a terrible fish, but if you remember, we know vertical angles are congruent. So that means the measure of angle 6. It's going to be 50 or 99.5 degrees. Now we're looking for the value of the variable. We see that we have two angles that are adjacent, and their non-share sides form a straight line, so we know they add up to 180. So I have 180 equals 13x plus 5x. Well, what's 13 plus 5? Well, we know that's 18x. Divide by 18. X equals 10. Once again, we see that we have two angles that are adjacent, non-shared sides. So we see that we have 4x plus 12 equals 2x. Oops, that's not right. Plus 12 plus 2x equals 180. We end up with 6x plus 12 equals 180. Got to get that x by itself. Subtract 12, subtract 12. That gives me, I'm going to go over here. Well, I say that, but there's really not a lot of space. So we're going to go 6x equals 8, 7, 6, 1. So 168 divided by 6. When we divide by 6, what do we arrive at? Let me grab my calculator out really quick. Okay, 168 divided by 6 gives me 28. X equals 28. Okay, this is a question that involves us using the diagram to complete the statement. Well, we see that JHL, we want to find the measure of JHL. Well, to be able to find the measure of JHL, we have to use some other information. So JHL is this one right here. Well, we know part of it. We know the 60 degrees, but we have to figure out something here. Well, looking at this diagram, we really don't have a lot of information other than vertical angles, which happens to be what we have to use. So to find that, we have to use the fact that this is 46 degrees. So we are able to use 60 plus 46 equals 106 degrees. Our next one up is to find JHN. I'm going to clear what I just had with my picture so I can use other information. I don't mind leaving this knowing it's 46 degrees. But now we want to find JHN, which is this part of it. Well, we know nothing other than this is vertical angles, or we can use the fact that right here is a straight angle, so we know that that's going to add up to 180. That might save me some time. So I can do 180 minus 60 minus 46, which gives me 74. And then once we have that 74, which we know is this portion here, 74. If I can draw a 4 there, we know the answer is going to be 74 plus 46, which gives me 120 degrees. And last but not least, we have KHP. right here. We did some math in that last one, and we found that this was 74 degrees already. Since that one we know is 74 degrees, to find this one, all we have to do is 60 plus 74, which gives me 134 degrees. Our next group says write the statement as an if-then statement, then underline the hypothesis and the conclusion. So remember, the if part is the hypothesis, the then part's the conclusion. So if we wrote this one out, we'd say if a tomato is right, so what's the effect? Then it is red. So if we're going to underline the hypothesis, it's the part not including the if. Or circle the conclusion, it's not including the then. Over here, you will need an umbrella if it is raining. Well, this one already has part of it with it. We see the if it is raining. So if it is raining, then you will need an umbrella. So the hypothesis again is the if part without the if. The conclusion is the then part without the then. Circled there. We see in here that all of the little lines that are supposed to be above the names are moved. So name 3 lines that appear to be parallel to CD. We see that CD is going to be right here. This is the D. You can't really see it. But CD right here, well, we have named name 3. When we see AB appears to be parallel, so let me come over here. AB. We actually only need it to be segments. Another thing that would appear parallel is this FG. And then last but not least, HE. So those are the ones that appear to be parallel. The next question has to do with skew. So here we have skew. It says name 2 lines that are skewed to GH. GH is right here. So remember, to be skew is it's not going to be in the same plane, and it's not going to be parallel. So we need to be going the opposite direction. So we see here that we have FB. Don't lie in the same plane, not going to intersect. And another one that we see would be CF. They're not parallel, they're not going to intersect. So name a plane that appears to be parallel to the plane ABE. Okay, so let me erase this again. Parallel ABE. So we see that would be like our left-hand side of our classroom. So a plane that would be parallel to it, it would be like the right-hand side of our classroom, which we'd name just plain any 3 letters there, combination. I'm just going to do CFG. Again, remember there's a D up here at the top. And then the last one here says find a line that's perpendicular to AB. So we have AB right here. For it to be perpendicular to it, it's forming that right angle. So we see that AH is perpendicular, and so is BE. So forming the right angle with those. Now it says find the value of x given the fact that RS is perpendicular to TU. So we see here that we have our right angle. So that means we know this side over here also has to be 90 degrees. Since we have 2 angles adding up to 90 degrees, that's x plus x, which gives me 90 degrees equals 2x. We know if we divide by 2, x equals 45 degrees. Once again, we have to use that same fact, so we know that since this is a straight angle, this is 90 degrees. The other one has to be 90 degrees. So we have 2x plus 18 equals 90. So we now end up with 4x plus 118 equals 90 degrees. Subtract over 18. You get 4x equals And then when we do that math there, you're going to end up with something that's going to look like, borrow here, 2, that gives an 8, 72 degrees, divide by 4. We end up with 72 divided by 4 being 18. X equals 18. Okay, let me clear the slide. Okay, use the diagram to describe the relationship between the pair of angles. We have 2 and 6. We see that those are corresponding, same position, core angles, same position in reference to their line and to the transversal. Our next one up, you see that you have 3 and 6. 3 and 6, we see our alternate interior, alt, int, angles. 1 and 8, alternate exterior angles. Opposite side of the transversal, outside of the lines. And then the last one here, we have 4 and 6, both inside the lines, same side of transversal, so same side interior. Okay, so we want to find the measure of angle 1. So this one involves a little bit of finding positions. So we see that we have 37 here, so by alternate interior angles, this also would be 37. Looking at the relationship between these two, we see that this is a linear pair, so we do 180 minus 37, which gives me 143 degrees. Over here, we see that these two are same side interior, which we know are supplementary, so we have 180 minus 109. Remember that number 1 there shows that it's just the reference of which angle you're naming, which gives me 71 degrees. Okay, now we're on to finding these. So we have 57 degrees, and we have to find a relationship. Well, you see that there's no relationship between y and 57, but there is a relationship between 57 and x. This one would be 57 degrees based on the fact that they are corresponding angles. And then these two, x and y, are going to be linear pairs, so it means they're supplementary. So we do 180 minus 57. 180 minus 57 is going to give me 123 degrees. So we have x equals 57, y equals 123. Now we have the kind of a reverse situation. We have corresponding angles. X is going to have to be the same value as 5y because they're corresponding. We need to find what that value is. So we see x and 50 are going to be supplementary because they're linear pairs. So we do 180 minus 50 is going to give me x. Well, that's 130 degrees. Well, we know that x and 5y are in corresponding positions. That means that we have 5y equals 130. We divide by 5. That means y has to be 26. Explain if these are parallel and how we know. Well, here you see that they are parallel because corresponding core angles are congruent, and that only happens if the lines are parallel. So yes, parallel. Our next one up, we see here that we have M is parallel to P, and you see it by these little arrows. So we have that M is parallel to P, and we see that P is parallel to N. And therefore, we see by the transitive property that M has to be parallel to N because they are parallel to the same things. And then here we want to see if these are going to be parallel. We only have the same side interior angles. Well, if it's parallel, remember those are going to be supplementary. So we have 180 degrees. We have to see if it equals 180 degrees. 125 plus 55, which is going to give you 180, which shows that they are supplementary, so therefore, yes, parallel. The next one says describe the translations using words and coordinate notation. So I'm going to look at any point that goes to the same one that's the image, to the prime. I'm going to go B, to B prime. Well, we see I went right. How many? So we see 1, 2, 3, 4, right 4, and down it appears to be 3. So that's how you write it in words. Remember, when we write it in coordinate notation, it has to be x comma y, arrow. X right is positive, so plus 4, y minus 3, because you're going down. Over here, again, we're going to look at these. The easiest one for me to see now is A. So we see we go left 1 and down 2. So that's, whoops, I almost did that backwards. So here we are actually going from A to A prime. We go up 1, 2, and then right 1. So right 1, up 2, x comma y, x plus 1, y plus 2. Now it's wedged in there, but that's a plus 2. Okay, so now we are classifying these as different types of triangles. So right now, if you look at these, we would see this would be a right triangle. You see that the side lengths are all, or angle lengths are all different. So you used to know that the angles or the side lengths aren't going to be that either. So you know it would be scalene. So let me say that again. Remember that angle measures reflect which side is going to be the biggest side. So you know that none of them have the same angle. So therefore none of the sides are going to be congruent. So we know that it's going to be scalene. Over here you see that you have 104, which tells you this is going to be obtuse. And then we have 2 38s. Well, those are the same, so that means that the sides opposite them have to be congruent. So remember, 2 congruent sides would be isosceles. Okay. Here you see you have 3 congruent sides, which means it's equilateral. And that means it's also equiangular. You see that we have a 3, 4, 5 triangle, which we know would mean that this would have to be scalene. But we don't know for sure what the angle measures are going to be here. But if you look at these numbers should look a little bit familiar. It's a Pythagorean triple, so we know that 5 squared equals 4 squared plus 3 squared. 25 equals 16 plus 9. We see that that's true. 25 equals 25. So this has to be a right triangle. So this is scalene right. Down here we're looking for the missing number. Well, you know the sum of the interior of a triangle is 180. So we have 180 minus 40 minus 62, which leaves me with 78 degrees. To find the exterior angle, remember that is the sum of the 2 non-adjacent interior angles. So we know to find the measure of angle 1, we have to use 120 and subtract 60. Well, that means the measure of angle 1 is going to be 60 degrees. Once again, you have the same thing. Exterior angle means that the sum of the 2 non-adjacent interior, so 60 plus 45, which gives you 105 degrees. Okay, and one more page done. Moving on. Okay, sorry, I don't know if I didn't see these on the first page or if this is a separate picture. But now we only have 7 and 8 to do on this one because we did the other one. So you see that you have 2 30-degree angles, which means the sides opposite of them have to be congruent. So that means that 7 has to equal x plus 5. So for solving for x, we're going to subtract 5 on both sides. It means x equals 2. And over here, we have the sum of the interior of a triangle. We see you have 3 congruent sides, which means all the angles are congruent. If you don't just remember that this is 60, you can do 180 divided by 3 to arrive at 60 degrees. And then we take that 3x and set it equal to 60. We divide by 3. X equals 20. That looks like a 28. I'll rewrite it, 20 degrees. Okay, so here again, you see you have an equiangular triangle. You know if it's equiangular, it's also equilateral. 21 equals 4x plus 1. Subtract over 1, you end up with 20 equals 4x. Divide by 4. X equals 5. Again, you see that you have 2 congruent sides. Well, Angles opposite of congruent sides are congruent, which means that x has to equal 75. That's probably my favorite one on here, the least amount of work. Now we're on to the section that requires us to use Pythagorean theorem. Remember, that's a squared plus b squared equals c squared, where c squared is the biggest side, which is the right angle, the side across from the right angle, so that's the hypotenuse. So in this one, that's the 26. 26 squared equals 10 squared plus a squared. If you have a calculator, this is a good time to use it. 26 squared is a big number, 676. 10 squared is 100. Plus a squared, subtract over 100, subtract over 100. We end up with 576. To get a by itself, we got to square root both sides. A equals 24. Pythagorean theorem again. So we see that our hypotenuse is c squared. So it's going to be c squared equals 40 squared plus 9 squared. Well, 40 squared plus 9 squared gives us 1,681. C squared, square root both sides. C equals 41. And last but not least, to this group, we see we have c squared here is 10. So c is 10. So c squared would be 10 squared. 8 squared plus b squared. So that's 100 equals 64 plus b squared. Subtract over 64. I'm going to try to write that in there. You end up with 36 equals b squared. Square root both sides. B equals 6. I'm hoping I'm going to have enough room for this. I'm going to write your distance formula out. I'm going to change colors so you can write it with me. Make sure you write it down if you don't remember this. AB equals the square root of, and then it's x2 minus x1 squared plus y2 minus y1 squared. So x1, y1, x2, y2. So AB equals the square root of x2 is 3 minus x1 is 6 squared plus y2, which is 1, minus y1 squared, which is 5 squared, which gives you negative 3 squared plus negative 4 squared goes to 9 plus 16, which is the square root of 25. Well, 25 is a perfect square, which gives you 5. I'm going to erase my math from the last problem over here, so that way I have some space. We're going to do the same thing again. x1, y1, x2, y2 brings me to x2, negative 1 minus x1, or 7 squared plus y2, 12 minus y1, 3 squared. So negative 1 minus 7 is going to be a negative 8 squared. And then negative 12 minus a negative 3 makes that a positive. So 12 plus 3 is 15 squared. That gives me a total of 289. If I square root that, I get 17. Okay, double check my math there. See you on the next page. Okay, this is talking about classifying the triangle with the given side lengths as acute, obtuse, or right. So remember, this is where we take our bigger side, our biggest side, we square it. All of these are 3. And then we square the other 2 and we see what is bigger. So we have 9 box, and then 9 plus 9, which is going to be 18. Well, you see that that other side is smaller than the 18, so this has to be acute. We use our bigger side here, which is the 25, so 25 squared, box 15 squared plus 20 squared. So 25 squared gives me 625, box 225 plus 400. You see that this gives you 625, box 625. They're the same, which means the Pythagorean theorem holds, which tells you it's right. And then last one here is you have 17 squared, box, our 2 smaller sides, 9 squared plus 12 squared gives me 289. Box 81 plus 144, 289 box, that ends up being 225. You see that your c squared is bigger, so this has to be obtuse. Okay, we're moving on. We're now to the second to last page. Yay. When we look at these, this brings us back to the centroid. So remember, that's where your medians meet. And then we had special distances here. So you know that U is the centroid, and we know that RV, the whole thing, is 42. Remember, the part by the point is 2x, the part by the side is x, and we want to find the length of the two parts. So we have 3x equaling 42. Divide by 3, x equals 14. We have 2x to be your length of RU, which is 2 times 14, which is 28. Down here we have UV, which is just x, which is just 14. This one says you're going to name the sides from smallest to largest. Oh, let's try this again. Name the smallest to largest angles. So remember, smallest to largest, smallest and largest. Whew. So smallest angle is going to be across from the smallest side. We said that's going to be the 23, so the angle across from that is angle A. So angle A is going to be our smallest. The largest angle is going to be across from your biggest side. We see 34 is your biggest side. The angle across from it is angle B. Then we move on here. Name the shortest and longest side. So it's just the reverse of what we did. So the sides that are going to be longest, so longest side, shortest side. Well, the longest side is going to be across from the biggest angle. We see the biggest angle is angle F. So the side opposite of that is DE. Shortest side is going to be the one across from the smallest angle here. That's going to be FE. Okay, I'm going to switch the side to bring us to our last section. Okay, here we see, given that we have triangle ABC is congruent to triangle XYZ, determine if the angles are congruent or whether congruent angles are side. So remember, this is all about positioning. So angle B is the second position, so the one it's congruent to has to be angle Y because it's in the same position. Next, we have side AC. Well, we see AC is going to be the last letter and the first letter, so that means that it's congruent to the last letter and the first letter, XZ. We have angle Z. Angle Z is our last one, which means it's congruent to our last one in the first part, so it's congruent to angle C. And then we have YX. YX are the first two, but written in reverse. So that means it's the first two here, written in reverse, BA. So that's a nice refresher. Now we want to see which congruence do you need to show in order to indicate the indicated postulate or a theorem. So here it tells you side, angle, side. Well, if you look at this picture, you see that you have a side, you have an angle. The other thing is we need is the other side that makes that the included angle. So we need to show that BC is congruent to EC here. Over here, we want to use angle, side, angle. So if you look at your picture, you have an angle. You don't have a side and you have an angle. So what we need to show here is the included side. So we need to show these two. So we need to show that GH is congruent to KJ. And then the last part of this page says, does the diagram give enough information to show that the triangles are congruent? If so, state the postulate. So you see you have side, side, and by reflexive property, we have another side is congruent to itself. So yes, side, side, side. Here you look, you have angle, angle, angle. That's not what I taught you, so no, not enough info. And then over here, you see that you have two sides and an angle, which normally makes a bad word. We know we can't use it, but in this case, it's a right angle. And if it's a right angle, means it's a right triangle. Right triangle says if you know a hypotenuse and a leg, so yes, by HL. Last page. Okay, here we see we want to know what type of reflection this is. Well, you want to know if it's reflected over the X and Y. Well, we see it's if you bended the paper over right on top of the line I just drew, that would mean it's reflected over the X-axis. So across X-axis. Here you see that if you bended the paper over the Y, we would see it'd be Y-axis, but it's not actually lined up exactly here, right? The D does not line up with the B, it's over, so this would be neither. And then the last 3 questions just is about line of symmetry. So where could you fold the paper so that it lies right on top of each other? Well, you see that you'd have a line of symmetry directly down the middle. and directly down the middle the other direction. So if you folded those on top of each other, that H would lay on top of them. Here, this looks like part of like an upside down V, but you see if you folded it over on top of each other, it would not line up. So this has none. And the third one's not there, but it was originally supposed to be a heart. It's not a very good heart, but imagine it was the same on both sides. So the axis of symmetry would be coming straight down that middle. And so you'd have 1. So here we have 2. Here we have 0. And here we have 1. Okay, guys, thanks for watching the review. Bye.